Question C, you will see that there are three surds. There are three surds in this equation. So if you have three surds, you just need to know that, you just need to make sure that one of the surd is on one side. Okay, just if you look at this equation, that it has been just in place. One of the surd is just on the one side already, so you don't need to think a lot. You just do the squaring both sides, the first SBS, because you want to eliminate the square root. So you have to do it carefully by just writing the expansion carefully, and then on the right hand side, you know the answer is only x plus 2 because square root means the square will disappear. And now you want to do it carefully by multiplying slowly. 3x plus 1. Use another color to show the next part of multiplications, which gonna give you negative square root of 3x plus 1 times with 2x minus 1. Why do I leave some spaces over here? Because I know it's going to multiply the same thing, which is a double of the previous part, which gonna give you 2 times. And the last part will be purple color, will be this one. You're gonna get a positive 2x minus 1 solely equals to the x plus 2. Now solve it, simplify it nicely, and you're gonna get that this is 5x, 1 minus 1 cancel out. Bring this part to the left hand side, which gonna give you minus x minus 2 equals to positive 2 square root of 6x squared minus x minus 1. You solve this inside of the square root, and you're gonna get that 4x minus 2 equals to 2 square root of 6x squared minus x minus 1. And this is where you want to make the remaining set as single as possible, meaning we don't want this 2 here. To make it simple, we divide it to the left hand side part, right? So it will become 2x minus 1 equals to only the square root of 6x squared minus x minus 1. Therefore, you have got the remaining sets solely. You don't have any other coefficients over there. You will be easily squaring both sides again, SBS again, all over again and again, until you cannot see any surds anymore. That's only the trick. Very easy. So now you expand it, you're gonna get 4x squared minus 4x plus 1. Therefore your square root disappears, and now you simplify it, solve it, rearrange it. You're gonna get 2x minus you're gonna get 2x plus 3x minus 2 equals to 0. And now you can factorize it. Use your calculator. So 1 and 2. So positive minus equals to 0. Therefore your x is equals to 1 over 2, or x equals to negative 2. So now you are not yet finished. You must do, what do? You must do checking. Now let's do the checking part. What color should I choose? I'll choose a light blue. Okay, check for x equals to half first. Okay, shall we do that? We check the half first. So by doing that, write it down the left hand side of the first equation. What I meant is the original equation, 3 times half plus 1 minus the square root of 2 times half minus 1. Use your calculator directly and you're gonna get the square root of 5 over 2. And please do also check your right hand side, whereby the square root of half times 2 gonna give you, half plus 2 will give you square root of 5 over 2 as well. Therefore your x equals to half is accepted. Okay, now I use another color to check another x, which is x equals to negative 2. So be careful again. Don't forget, how many times do we repeat this? You must always and always take the first equation. Okay, checking must always the original equation. So left hand side equals to the square root of 3 times negative 2 plus 1 minus of square root of 2 times negative 2 minus 1 gonna give you negative 5 inside of the square root minus negative 5 also, and you're gonna see that, oh my god, surd negative value. When you press in your calculator, surd something negative, will you get an answer? No, you will get a maths error, or we would say it as undefined. Therefore your x equals to negative 2 is rejected, since surd cannot be negative. Just like that. Okay, and our right hand side can be ignored. We don't have to write it because we know this number has been rejected. Therefore our final answer, our final conclusion is the only x equals to half.